All right, guys, today we're going to look at our trig ratios. Again, just a couple of few things. I know last week we just basically did primarily the notes, didn't have the videos. But a couple things, just make sure you're keeping up with things every day. Make sure that you're showing work. That's a big thing. As most of you are, but some people are still not showing work. If you don't show work, you're not going to get credit. Have to show work on all the problems. Make sure you keep up with everything daily. If you're 2-3 days late, I'm going to have to take a point off, and even more if it goes in the next week. So I can't emphasize enough how important it is to keep up with everything daily. If you have any questions, please email me with those questions, and in most cases I've been able to figure it out. Or if you have any type of issues, definitely email me. Okay, what we're going to look at today is the trig ratios. Now, with the trig ratios, you are going to look at situations where you're going to end up getting y equal to something, or a number over y, or a number over x. And the way I want you to handle that is just by setting up proportions. All right, this is a good way of how, a good example. This one is going to show you how a lot of your equations are going to end up being set up with these trig ratios. And all I want you to do is, if you end up getting something like this, just put your decimal, or whatever you have, over 1. And then that makes it a proportion that we can multiply through cross multiplication. A lot of times you say to yourself, geez, all I had to do was multiply both sides by 18. You can definitely do that, but what I'm showing you with proportions is a one-size-fits-all, especially when we get to number 2 in the warm-up, where you have the y, or the variable, on the bottom. So we're just going to get x times 1 equals 18 times 0.875. And then when we multiply that out, you get that on your calculator, you're going to end up getting x equal to 15.75. X is going to equal 15.75. And if you want to round that to the tenths, that's not a problem. I just did this to the hundredths at 15.75. Now, when we get to the second one here, you're really going to see why I'm setting this up as a proportion. Okay? Because here you have your variable on the bottom. Again, if you just go back to putting it over 1 there, you're going to get y. Remember, cross multiply. Y times 0.5 equals 24 times 1. Okay? So in this case, we're going to, again, divide through by 0.5, divide through by 0.5, and we're going to end up getting our y equal to 48. Okay? Y is going to equal 48 in this situation. Okay? So all we're going to do is cross multiply here to get this. Okay? Same thing here. We see this set up like this. Just put it over 1. Okay? It sets it up as a proportion, and we do what we always know how to do with proportions. We cross multiply. Y times 1 equals 25 times 0.96. And when you multiply that out in the calculator, you're going to get an answer of y equals 24. Okay? So this basically sets the table for what we're going to do with trig ratios and how we're going to handle problems that are set up in this manner. Okay, I'm not going to bother with 4 and 5. It's basically the same type of thing. Okay, here are your trigonometric ratios. Okay, and ultimately, what this is going to allow us to do, it's going to allow us to find measurements of sides. And when we deal with inverses down, the road, it's going to allow you to find measurements of atoms. But that's for when you get to trig. We're just basically giving you a feel for this, giving you an intro into the basics of trigonometry. And with the trigonometry, you have your trig ratios, your trig functions here. You have sine, cosine, and tangent. Okay? And they all deal with a right triangle. So Again, you have to understand we're going to deal here with a right triangle. And as we know with the right triangle, we already know that our hypotenuse is going to be directly across from our 90-degree angle. That corner always points to it. And then here, you've got one leg and you've got another leg. Now, when we're looking at these legs, we're going to deal with them off of whatever angle we're talking about, okay? So they're talking about angle A. They could have said angle B, but here they're talking about angle A, okay? With angle A, first off, you're always going to identify this as your hypotenuse. Identify that first. Label that first. And that regardless of what angle you're talking about, here they're talking about angle A, this is always going to be your hypotenuse. The one directly across is going to be your opposite leg. The one that runs alongside is going to be your adjacent leg, okay? I always say, pick the adjacent leg first. It's going to be the one that runs alongside of the angle that isn't the hypotenuse, okay? So this is your adjacent leg. By process of elimination, this is going to be your opposite leg. Now, they're going to ask you for the different ratios. If you're asked for sine, that's going to be your opposite leg over hypotenuse. So if I'm looking for the sine would be opposite over hypotenuse. And you're going to see how this comes about in a couple of examples that we're going to have. Okay? Cosine is going to be adjacent over hypotenuse. Okay? And tangent is going to be opposite over adjacent. And I'm probably going to write down these ratios off to the side here so we can see them when we're actually doing a problem. But these are your trigonometric ratios, better known as your trig ratios, sine, cosine, and tangent. We're just going to deal with these three. Down the road, you're going to see three called cosecant, secant, and cotangent, which are going to be reciprocals of these. But we're just dealing right now with sine, cosine, and tangent. Okay? Okay, they want you to find the sine, cosine, and tangent of S. Then you're going to find the sine, cosine, and tangent of R. Okay? Let's look. Again, our ratios are sine is going to be, and we'll first call it of S. Sine of S equals your opposite over your hypotenuse. Cosine of S equals your adjacent over your hypotenuse. Tangent of S is going to equal your opposite over your adjacent. And I just abbreviate that. Now, this is the most important thing with what we're doing here. Okay? You've got to come over to S. Again, this is R up here. Okay? And we're going to identify everything with respect to S, because we're initially going to find our sine. I'll put this up here as a little bit above. In your notes, you'll see you have sine S. Okay? We're talking about angle S here initially. Okay? First off, this is always your hypotenuse. Whether we're talking about S or R, that's always going to be your hypotenuse. All right? We need to find our opposite side, our adjacent side. Remember, if we're talking about S, our adjacent side is our side that runs alongside. So adjacent is going to be the 12. Your opposite side is across, or it's the only one that's left now. This is your opposite side. Okay, so that's going to be your opposite side. So with respect to S, again, the first three that we're going to do are with respect to S. Your opposite side is 5, your adjacent side is 12, and hypotenuse is always going to be 13. Okay, so our sine of S, sine is opposite over hypotenuse, so our sine is going to be 5 over 13. Sine is opposite over hypotenuse, so our sine is going to be 5 over 13. Okay? Our cosine of S, that's going to be your adjacent over hypotenuse. And your cosine of S is going to be 12 over 13. Your tangent of S, that's going to be your opposite. Tangent is opposite over adjacent. So it's going to be tangent's opposite over adjacent. So your tangent is going to be 5 over 12. And again, this was all with respect to angle S. Okay? All right. So now they're going to ask you about angle R, finding the trig ratios for angle R. You've got sine, cosine, and tangent. So all we're going to do now is change this. Instead of S, we're going to find R. Erase this. Now again, now we're talking about angle R up here. Okay? As far as angle R goes, and we'll erase this. This was from S. Okay? Your hypotenuse, whether it's R or S, is always going to be that 13. This is always going to be your hypotenuse. Label that first. Okay? Now, when we're looking at R, our adjacent side, the side that runs alongside of it, that's not the hypotenuse, is going to be this, the 5. Okay? Our opposite side across from it is going to be the 12. Okay? Now they're asking you for the sine of R. Sine is opposite over hypotenuse. Okay? Opposite over hypotenuse. First time around, I write a lot more than I really need to, just to be thorough. You can write as much as you need to write, but make sure you're showing work. So my sine of R is going to be, look at R, it's going to be opposite over hypotenuse. Okay, so my sine is going to be 12 over 13. Okay, my cosine of R, cosine is adjacent over hypotenuse. My cosine of R is going to be adjacent over hypotenuse. And that's going to leave me with adjacent over hypotenuse, and that's going to be 5 over 13, adjacent over hypotenuse. And the last one I find is my tangent. My tangent is opposite over adjacent. Tangent is going to be opposite over adjacent, so that's going to give you 12 over 5. So those are your trig ratios and how you're going to handle each angle. And this is a little trick. When we do this, you'll be able to look back and look at your trig ratios. A little thing that, a phrase that helps you remember that is something called SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse, right here. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, O over A. So it's just something to help you remember that. That's good if you're on a standardized test or whatever. You're doing something where you don't have time to look back and reference the different trig ratios, something that might help you out. Okay, so those are the trig ratios, and that's how we're going to handle that in when we're dealing with different types of triangles. Okay, now the other thing you're going to do is you're going to use your calculator a decent amount here, and bear with me a second as I look for our eraser here. Knock it off the desk. Okay, when you're using a calculator, the biggest thing is to make sure that you're in degree mode when you do this. Okay, if you have a graphing calculator, you're going to go to mode. Just write this. Go to mode. Okay, and you're going to go down to down arrow to degree. It's the third one down. You'll see radian or degree. Down arrow. Okay. You'll see if you go to mode, press enter. You're going to see radian and degree. Move over to degree. Make sure that's highlighted and press enter. That's if you have a graphing calculator. If you don't have a graphing calculator, you can put your phone sideways. Go to calculator. Put your phone sideways, and you're going to end up giving yourself a scientific calculator, which you can definitely use to do this. Okay. And again, the thing about that is there's a couple different phones that have different types. Most of them are pretty much the same, but some of them have subtle differences. So what I would advise you to do is get your phone, put it sideways, and to make sure you're in degree mode, just test it with these problems that I'm going to give you right here. Okay. The first one that we're going to have is sine of 74 degrees. Okay, so we type in sine, and then we put 74. Okay, and then you're going to end up getting 0.9613. Okay, for your sine of 74 degrees, 0.9613. Cosine of 74 degrees, okay, we go to the cosine, that's going to end up giving you 0.2756. 0.2756. Okay, 0.2756. So if you put your phone sideways, you'll see sine, cosine, and tangent will come up. And sometimes what you may have to do on some of them, you type in the number and then push either sine, cosine, or tangent. Like I said, some of the phones are different that way. But you can test it on these three. Okay? And then if we had tangent of 74 degrees, tangent of 74 degrees, that's going to be 3.4874. 3.4874. Okay, so that's basically just a matter of using a calculator for all the problems that are like this. And you'll see that on your sheet. And again, as we've been doing, you're going to get notes that are filled out, but you're also going to get a worksheet where I'll do the first problem, first or second problem in each section. Okay, so that's basically how we're going to use a calculator to evaluate everything right there. Okay, now we're really going to see what these trig functions, these trig ratios are used for when we get to the types of problems that we're looking at here. I'm going to make this, see if I can make this a little bit smaller. Okay, see a little bit better. Okay, and I'll raise this up a little bit. Take everything off there. Okay, that's good. Okay, now, if you remember your trig ratios, or you'll have them to look at in reference them, sine is going to end up being opposite over hypotenuse. Cosine going to equal adjacent over hypotenuse. Tangent is going to equal opposite over adjacent. Okay, so there are trig ratios. Now, whatever angle they give you here, that's the angle you're going to use. All right? You can kind of see, and that one has a box, this is your 90-degree angle. So first thing we're going to look at and identify is our hypotenuse. Okay? Then the next thing, and again we're talking about with respect to this 59 degrees, is identify your adjacent. Adjacent is the one that runs alongside. That is not the hypotenuse. So this is your adjacent side. Your opposite side is going to be here. Okay? Now, here's where we got to pay close attention. you're going to solve this and you want to try to find x. Now, you want to use the ratio, and you have to figure out, first thing you have to figure out is what ratio you use. Do you use sine, cosine, or tangent? You're going to use the ratio that has the sides that have either the x or a number. And in this case, my two sides that have an x and a number are my opposite and my adjacent, okay? Hypotenuse doesn't have anything. There's no x, no number, so we're not using hypotenuse, all right? So come over here and see which sides use your opposite and your adjacent, okay? Not the sine, not the cosine, but it's going to be the tangent. Tangent uses the opposite and the adjacent. So we're going to come down here and have a tangent. This is the angle we've been using, 59 degrees equals tangent is opposite over adjacent. Opposite over adjacent. So we're going to put in for opposite here, that's going to be x, and adjacent is going to be 8. Okay, so we've got a tangent of 59 degrees equals x over 8. Now, there's a couple things you could do here. You could just, basically here, we're going to set this up as a proportion. Put this over 1, and we'll cross multiply. Now, what I want you to do is, just to see what's happening here, get the tangent of 59 degrees. Put tangent of 59 degrees in your calculator, and you're going to come up with a decimal. In this case, you're going to end up getting 1.66. 1.66 over 1. Okay, so I just put this in for tangent. Obviously, this is over 1. And then that's going to equal my x over 8. Now I'm going to cross multiply. 1.66 times 8 equals x times 1. Okay? I multiply that out, and I'm going to end up getting 13.31 equals x for my answer. So x ended up being 13.31. And we always say, look to see if it's a reasonable answer. If this is 8, they said this is 13.31, makes sense, right? If I got something like 120, you know you did something wrong, okay? So we can always check for reasonable answer. All right, so all I did was I tangent of 59 degrees, I went in the calculator and put in tangent 59 degrees, that gave me 1.66, put that over 1, I'm just replacing everything. And then I solved it like I know how to solve it. Now, if you want to, I basically did it this way so you can see what's happening. You could just keep it as tangent of 59 degrees, okay? Multiply that times 8, and then set it equal to x, okay? One of those little shortcuts you can have, all right? You'll probably do it that way, then moving forward, all right? So that's the first one right here, okay? We go to our next one when we're dealing with 30 degrees, okay? Again, this is going to be our hypotenuse, always, regardless of what angle we're dealing with. You want to cross from the 90-degree angle is going to be your hypotenuse. This is going to be the adjacent side runs alongside of it, okay? My opposite side is over here. We can clearly see the two sides we're going to deal with are our opposite and our hypotenuse, because they're the two sides that either have an x or a number, 7 here. Adjacent doesn't have anything, so we're not, on this one, not going to use adjacent. So if we're going to use opposite and hypotenuse, we have to go into the function that involves the opposite and the hypotenuse. You can clearly see the only trig ratio here that involves the opposite and the hypotenuse is your sine. So your sine of 30 degrees is going to equal opposite over hypotenuse. So that's going to be 7 over x, okay? I can put sine of 30 degrees over 1, all right? And if I put in my calculator sine of 30 degrees, I'm going to get 0.5 over 1, make it 0.5, okay? Equals 7 over x. I'm just replacing everything else that's here, okay? Now we cross multiply. We're going to get 0.5 times x equals 7 times 1. 0.5x equals 7. Remember, we know when we solve for x, this is 0.5 times x. Inverse multiplication is division. Whatever we do to one side, we do to the other side. This cancels out. We go in and we do 7 divided by 0.5, and we're going to get x equal to 14. Okay? So that's it for your trig ratios. Covered everything there. Couple things. You're going to now, this is a quicker unit. Now we're going into our unit test. You'll see that on the schedule. I know this is for work for today, for Monday. And you're going to go and review. I'll probably have you review a couple days for the unit test. This unit is, again, is quicker than the last unit. And then we'll have our review Tuesday and Wednesday. Thursday will be your unit test. And then Friday, I may have just an overall activity Friday so we can start fresh on Unit 3 on following Monday. Okay? Again, have any questions, definitely email me. Keep working, keep up to date, and make sure you're showing your work.